Good evening, everyone. Am I audible?
Yes, ma'am, audible.
Okay, let me share my screen. So, we'll be starting with week 3 today, okay? Have you gone through the lectures? No.
Yeah,
Okay,
ma'am, only some of the lectures.
okay, yeah. So, week 3 will start discussing the object oriented programming concepts in a detailed manner, okay? So, we start with something called what is program. Basically, it is a mix of algorithm and data structure. Algorithm means the step by step instruction itself, and data structure is where exactly we store the data, right? And we have different type of programming like structured programming, object oriented programming, right? So we if you look at structured programming, what they basically do is they'll design a set of procedures for some task, which means they'll write methods or functions. Okay, and these methods they'll write multiple methods and they'll combine this to build the bigger system, the complex final system. That is how structured programming works. And when you write methods, you basically will pass the parameters and all, right? And the data representation comes later. Maybe you will design the linked list and everything later, but methods will design earlier in structured programming. And that is how structured programming is. And if you come to object oriented design, it's the opposite. Here, though, you see, first we design the set of procedures, methods first, then comes the data representation. And object oriented design, what we'll do is we'll try to find the objects, we'll find the data that we have to work on. For example, if you are going to build an employee management portal or something for a company, what they will do, they will first see what are the classes that they want, like employee class, manager class, other classes related to the payment related thing, pay slip, sorry, pay, yeah, slip only, those kind of things. So they will first try to get the objects, right? Which means we are basically finding the data to work on. And on top of that, once you find the objects, then for objects you will have the properties, correct? For example, if you just identify employee object, then employee itself has some properties like name, gender, age, etc. These can be called as properties. And then you can write the methods, which means basically you're designing the methods or functions to operate on these data, correct? So we will also have salary as an attribute or a sorry, property of employee, right? You can have a method that will do some manipulation for this salary. When you do increment, you have to increase the salary, right? Then you will call the method that is suitable to increment the salary of that employee. So which means first we'll identify the data, the object, and then we'll write the algorithms to operate on the data. That is object oriented design. Is the basic thing clear?
Yes, ma'am.
Okay. So here we have a small example comparing a simple web browser. So initially this is done in, if we go with the structured programming, then we'll write some 2000 methods manipulating global data. So we will store the data as a global data. So any method can access that global data. And we'll have some 2000 methods. Okay. And if we do the same simple web browser in object oriented design, then we'll write some 100 classes, and in each class we'll add around 20 methods. So this is just an example, okay? So 120, all these 2000 methods are included in this manner, classes and methods. And this is a easier way to grasp the design, and also the debugging will be very easy. So if you find any method is not giving a proper output, or some object state is getting disturbed by something, then you just have to take that particular class and then do correction on that. So debugging is easy when we have object-oriented design. Search among 20 methods in that particular object rather than all 2000 procedures comparing to structural programming method. Is that okay?
Yeah, ma'am.
Okay. Next, so this is an example for object-oriented design. We are going to design an order processing system, just like Amazon or Flipkart or something like that. So first thing, we have to identify the objects, correct? Those objects will convert into templates, which are basically classes. So items, orders, shipping address, payments, accounts, all these are objects, real world entities that we are going to work on, correct? And then what are some things that will happen on these objects? The verb thing, action thing. This action thing is actually the methods that we will write. For example, items are added to orders. So which we know, right? We'll take the item and we'll add to the cart, or we'll add to the order, correct? And then order orders are shipped. So when they start the inventory, so they start with the shipping, right? Shipping is an operation. Then we may cancel it. So cancel is an operation. So orders can be cancelled. Payments are accepted. This can be one method. Accepting, rejecting can be another method. So all these actions can be converted into methods of these objects. So these are the objects and these are the methods. Is that clear?
Yes, ma'am. Clear.
Okay. Then we'll learn few terms related to these objects. Okay. One is behavior. Then yeah, behavior is nothing, just like the methods that we write in a class. Okay. In student class, we may write something like find average for find sum. Okay. So if we have marks of different subjects, we can have a sum, we can get the sum of the marks, right? We can get the average of marks. So that is behavior. What methods we can operate on these objects. And state means, so here it is again, how does the object react when methods are invoked? Or easily what we can say is, when we create an object, we will initialize the instance variables, right? Anyway, these variables will have some value when you create an object. If you create a student object, you'll give a name and age, correct? Which means, suppose S1 is the student object. State of S1 means the data that we store for these instance variables, the name and age. Is that clear?
Yeah, ma'am. At the type of declaration or initialization, what value we give, that is state.
Yeah, right.
Okay.
Or later also we can change the state of object using the behavior, using the methods.
Behavior is operations that we can perform.
Correct. Behavior is the operation or the methods that we can operate on the objects. So using the behavior, we can change the state.
Okay, ma'am.
Yeah. Now identity. So these all these are related to objects. Okay. So identity means, as you know, it's like unique feature that will distinguish between different objects of the same class. A class can have multiple objects, right? I mean, using the class, we can create multiple objects. So we may have two objects which may contain the same item, which means the state is same. The name and age will be same for a student, two student objects, but still they are different. Correct? For that we can have this identity. Anyway, when you create S1 object, a part of memory, a heap memory, it will create an object for S1, and for S2, it will create another, it will allocate another chunk of memory, right? So these two are different. So anyway, the reference will point to, S1 will point to one object and S2 will point to another object. So there will be something, some memory address will be there. Anyway, that is not seen by us. We may we have some methods to get some identity on this. Just like in Python, we have ID function, right? If you call ID on something, you will get the pointer, correct? something like that. So identity means which basically distinguish between different objects of the same class. So this is another feature of an object. Now these features interact basically means with behavior. It can affect the state of an object. Using the methods, we can change the information in an instance variable. We can change the name, we can change the age later as well using the public accesses or anything. Now these are something. So cannot add an item to an order that has been shipped. So this is like something logical thing that we should implement, right? So once the yeah once the item is gone to shipping, then you can't add that to order. That is something you have to consider. Then cannot ship an empty order. Yeah, that doesn't make sense. So these things you have to consider when designing objects. Is that fine?
Yes, ma'am. Fine.
Yeah.
Yes, ma'am.
Okay, then let's see some other terms that is related to relationship between classes. As I said, when we design these classes, we will have multiple classes, right? And we will use one class in another class, correct? So dependence is one word, and I mean one term. So order needs account to check credit status. Item does not depend on account. So these blue highlighted ones are classes, okay? Class order needs class account to check credit status, correct? So when you place an order, it will redirect to your account, correct? And you have to check whether the transaction is successful or not, whether it can be processed, first of all these things. So order class have a dependency on account class. And here, item class does not have any dependency on account class. They don't have any relation. Now, your voice is breaking. So I'll show with an example. So you'll learn more about this in software engineering course. So see this example, we have class calculator and this has a method add, okay? And here we have a class math operations and here I have a variable of calculator. Okay, and here you see perform addition. So math operation, I have a method perform addition that uses calculators add method. Okay, so this we can call it as dependency. So basically, math operation class is dependent on calculator class. Okay, I'll show some other example later. Let me complete this. Okay, is dependence clear? The term as it is.
Yes, ma'am.
Okay. The next one is aggregation. What is aggregation? Order contains item objects. So one class containing another class objects. So that is aggregation. Now to inheritance. What is inheritance? One object is a specialized version of another. We have seen this, right? We have seen manager class is a specialized version of employee class. Same here. We'll learn about inheritance in detail. For example, express order inherit from order. Order is a normal class which we will use to order something, and express order will have something additional to order class, like maybe will reduce the number of days for delivery, right? Such things we can modify in express order and create another class. But basically, it will inherit from order. It will keep all other things for an order and it will add something extra. Extra methods to compute shipping charges, priority handling, etc. will be added into express order.
It is extending of a parent class, right?
Yeah, right. It will extend the parent class order. Okay, see here, this is a very simple example. This is not how we actually do application development and all, but for understanding, you can just refer this. Okay, so I have this demo app package, and I have one class called cart, and I have product, I have shopping class, and user. These four classes. Okay, look at cart. Okay, let's start with product. Product. Okay, so this is exactly like a shopping website. Okay, so first we need class product. So for every product, first we have to identify the properties. Okay, I am identifying name. I want to store the name of the product and the price of the product. For that, I have two instance variables. And here I have the constructor, two argument constructor, parameterized one, which takes name and price and will initialize the variables name and price. Here I have get name to return name, getter, get price to return price, and one more method display product that will simply display name and price. Now let's see user class. In user class, I want username and a card. You see this? Here I have a card. What is this relation? We just saw relationship between classes, right? This is
Dependent.
segregation. No? No, this is segregation. So we are basically having another object inside a class. Okay. And now initializing username and card, get username. Then I have cart itself. So here uh, I have an array list. So think it of like an array, okay, a list, a normal list that can store more than one object. Okay, here I am storing array list of product. So basically, each element of this list will be product object. Okay, and here add product is a method that take a product object and it will add to this list. You don't have to understand it very clearly. Just understand the story here. Okay, and here I have view product, sorry, view cart. So printing something, and here I have a total variable, and here it will go through each of the element of the product in this item list, and it will call the display product and also add the total price here. Basically it will compute the total price of the cart, finally printing total. Now let's see one more class, shopping app. In shopping app I have three products. Okay, in this is the main class. Here I will create the object that I want. I'll add the product into the cart. Okay, those things I'll do here. So I have these three products, and the user I have created user object, and then calling the get cart method and adding the product. So get cart user dot get cart. So where is user get cart? This will return the cart itself, and the cart has add product and view cart method. Okay, and and here with that cart object that is returned by the user, I am calling add product p1 and p3 into my cart. Basically I am adding into my cart. Then finally printing welcome, and print the username using user dot get username. In the user class we have get username, right? That will return the name. And finally calling the user dot get card. This will basically give the cart object, right? And then using the cart object calling the view card. So this will display the whatever that is present in my cart, because in view cart you see this will be printed, and then it will go through each of the cart objects that I have in my cart, and it will print it, because it is calling display product, which will basically print that, it will display that. And then it will also print total at last, because here for every product, it will take the price and it is adding to the total variable. Yeah. Any doubt?
Yeah, ma'am. Could you please again quickly explain dependency and aggregation using this?
Okay. So here we can see, let's see, we have aggregation. We have aggregation, right? That is so. One is here itself, we can say array list of items, right? This is aggregation. We are using array list object inside a card. Okay. And uh, dependency, we can see this one, display product. We are calling the display product of another class, correct?
Okay.
Yeah. I'll add this to the drive folder itself. Maybe you can simply run and see. What we can do is we'll try to develop this throughout the weeks. Okay. So we will see all the concepts here itself. We have compiled product, right? Mm. There is some errors. I'll fix it. Uh, okay, I'll fix it and show you. Anyway, I'm not wasting time here. I'll just go with the topics for today. Okay, we'll start with inheritance. So look at this particular class employee. So we have class employee and we have two instance variables for employee, which are private instance variables, name and salary. And here we will add some constructors to set the values for these variables. Then mutative methods like set name, set salary, again to set values outside the class. Then we have accessor methods to get name, to get salary. And one more method we have is that bonus method that takes some percent and it will return some percent into salary. So basically it will return the bonus in this formula. Okay, so I'll just have this. Okay, that is this particular class name salary public employee. This is the two argument constructor. Here is the set name, set salaries, get name, get salary, bonus. Now, what we will do is we'll see the next slide here. Subclass. What is subclass? Now, see what is manager. So, in a company, we have employees and managers, right? Now, managers are special types of employees with some extra features. Now, what we can do is we can extend employee. Okay, we'll create a class manager that will extend employee. Now, manager will get all the properties and behaviors of employee, correct? And we can include more things here. We are adding a string instance variable secretary and set secretary method and get secretary method for class manager. Manager object inherit all other fields and methods from employee. Manager has a name and salary and methods to access and manipulate these from the employee class. Now manager is called as child class or subclass of employee here. So class manager, here it extends employee, it is having the secretary variable, and this is the constructor we have in manager. And if you see the constructor here, now you have to focus this area. We have a three argument constructor that takes name, second word salary, and then secretary. And name and salary is coming from employee class, right? And they are private variables. As you know, private variables cannot be accessed anywhere outside the class employee. Even in subclass, it is not accessible. So what we will do is we have this super call to the parent constructor. So when you call super of n comma s, what will happen is this particular call, super call, will actually invoke the constructor of the employee class. This particular constructor itself, because we are passing two arguments, and it will set the value for name and salary from the value that we pass while calling the constructor here. Super n comma s, n and s will be set for name and salary there. And then we will initialize secretary with whatever value that we get here. And rest are same. Set secretary is an additional method, get secretary is another additional method. And yeah, here, okay, this much we'll see, and this I will comment it now. Is that clear what we have done? We have class employee and we have class manager, extra variables. We have made little bit changes in the constructor here. Is that okay?
Ma'am, is subclass and subtype same thing?
Subclass and subtypes, conceptually they are not same thing, but in Java they are almost same. Yeah.
Like the same class that we are calling subclass, that is the subtype, right?
Yeah. Here we can say manager is a subtype of employee.
Okay.
Yeah. So let's create an object of manager m equal to new manager, and I have to give values for name, some name, age, and then we have secretary as well, right? Okay. So this will create manager object. Now I can call m dot get secretary. So I will get the secretary. Let's have one more call to the method of parent class get salary. Okay. Yeah, we got it. Now, one more point to remember is we can create reference variable of employee type, and it can point to object of manager, right? This is allowed because of subtyping, correct? And let me call here, we will see one problem. So when we have something like this is allowed. Creating object and all is allowed, okay? Don't confuse that. So get salary method we can access, and one more method we have is get name, right? Yeah. So get name, this is also accessible, okay? But what we saw is get secretary is not accessible. Yeah. So which simply means that if you see the capability of employee, it has get name, get salary, but not get secretary. Because of that, we are getting the error. So for employee, we don't have a get secretary method. So that is giving an error. Otherwise, we can have an object that is pointed by an employee reference variable. Is that clear?
Ma'am, if we create the get secretary method inside employee class, then would it be possible this?
Yeah. If we have a get secretary method in parent class, then you can
Ma'am, but
call it.
inside parent class, the employee has only two attributes. It doesn't have secretary attribute. How that
Right.
works?
So it doesn't make sense, right? Yeah. So that won't work anyway. Oh, the only we have a workaround for this. We'll see that. Okay. For now, just stick with this. I'll just go with one more topic.
Okay.
Yeah. So we reached super call, right? I'll add one more thing here. Suppose we are not calling this. Okay. Let's see whether we are getting any error. Constructor employee in class employee cannot be applied to given types. Okay. So we got an error because constructor call didn't happen. So that's why we got an error. Let's add. So you know this, right? So if we do not have a constructor in a class, then compiler will give a default constructor, which will initialize with null values. I mean default values, correct? Only
Yes,
in,
ma'am.
yeah, the case is we shouldn't have any constructors from our side. No user defined constructors. And now we have a constructor here. I want to remain it as it is. And I want to add a default constructor. So now if I want to add a default constructor, I have to do it manually, right? Explicitly, I have to give a default constructor. This is how the default constructor will look like. It won't take any arguments. And I can do anything here, not just default values. Anyway, I'll give name like some ABC, and okay. So this is my default constructor. Now let us see. Now we don't have any compiler error, right? Earlier, when we were not having this default constructor, we got an error. But now, what is happening to name and salary? That is getting initialized by this default constructor, right? But still, we have not given any explicit call to the superclass default constructor. Still, it's working, which means the first line of this constructor in the subclass is actually something like this. So this is basically a call to the default constructor of the superclass. Even if you do not give any explicit call to superclass default constructor, the first call will be this line, this call to the default constructor. Now this will also work anyway. If even if you are not giving, still it is working. Is that fine?
Hello, ma'am.
Yeah.
Yes, ma'am.
Yeah.
Yes, ma'am.
What is the working of super here?
Here it's not working. So here you just think it of like this. If you're having something like this, then in the manager constructor, the first line implicitly is a call to the default constructor of the parent class. Getting it?
Okay, by default it will call. Okay.
Yeah. So the only problem is if you have if you do not have the default constructor, and if you have any other constructor, then compiler won't give the default constructor, right? Then you will get errors. So you have to think about this kind of situation. Okay, that is the only catch here. Now I will remove this, and this I'll go with normal way of calling. Okay, no error. Okay, let's see more things. Some of the things that you have to keep in mind. One thing is subclass inherit all the instance variables and method from parent class, but still it cannot see the private components of the parent class as we have seen in the previous code, right? This name and salary you cannot access from the manager class directly. So you can access it through how the getters. Through getters you can access, and yeah, subclass can add more instance variables and methods, can also override methods. Okay, here you see this particular bonus method. This is present in class employee, and what it is doing, taking the percentage and returning in this format. Okay, yeah. Now what I want to do is in manager class, as it is extending employee, now the manager class using manager object, a manager object can call the bonus method on that object, right, and can find the bonus. But what I want is for manager, the bonus calculation should be different. So what I'm going to do is I'll redefine the bonus method. So what is redefining? You see the complete function signature. It is public double bonus, name of the method, and the argument is float percent. Okay, and if you see the bonus method here, same public double bonus float percent. You have to focus mainly on the name of the method and the arguments. Okay, float percent, and these two methods are same now, right? They are methods with same name and arguments and everything. And now only the difference is in the implementation. The implementation is different. If you see here, what I did, I took, yeah, here I have called the bonus method of the employee class using super. So this is super keyword. So you can access the methods of the parent class using super dot bonus of percent. In this way, this will invoke the bonus method of employee class, and we will get this amount where here in double B, and after that then returning 1.5 of that particular amount. So basically a different bonus for manager objects. So what we have done is we have given a new implementation for the bonus method for this particular class manager, which actually extends employee. Is that clear?
Yes, ma'am.
Yeah. So let's invoke bonus method Yeah, what is the problem here?
We have to pass a parent.
So I'll pass the percentage. Still, there is a problem with the, that is a float, right? So float you have to specify f. So we got the bonus here. Now, one more thing you can notice here is same. Still, our manager object is pointed by the employee class reference variable, right? But we don't have any problem for bonus method because bonus method is present here and here, correct? So here comes the concept called dynamic dispatch or late binding. So you can think it of like during compilation what happens earlier for get secretary we got an error because m is of type employee, and when you call m dot get secretary, it will check class employee whether it has get secretary method or not. As it does not have any method called get secretary, we got an error, a compiler error. But in the case of bonus method, what happened? M is of type employee, and it will check in employee class whether we have a bonus method. Yes, we have. So it passed the compiler check, right? And now during runtime is the actual creation of object, right? And the object is of type manager. And now m dot bonus is going to call the bonus method of manager class, which means according to the runtime object, runtime type of m, it is going to call the bonus method. Is that clear?
This object is of type manager or employee.
Object is of type manager. See the right side. Right side is the object creation.
But we define object based on the class in the left now, as we write string s equals to new string. So s is of string type and m is of employee type.
Yeah. Normally that is how we do, but this is also allowed. That is what I'm trying to say. So when we have subtypes, so in subtyping, this is allowed. So a more specialized type can be referenced by the supertype. So employee is the parent class, right? And manager is the object. So this particular way of creating object is allowed. And the
So
concept of
m is of manager or employee, particularly.
please repeat. Your voice was breaking.
No, I want to ask that m is of which type? M object is of which type? Manager or employee?
We can say M is pointing to an object of manager type. M itself is a reference variable of type employee. So the left side can be said, left side is reference variable which is of type employee. Okay. The type of the reference variable type is employee, but the object is of type manager. Clear? Yeah.
Ma'am, can you show the bonus method of employee class?
Code of employee class, you said, right?
Bonus.
Bonus. Yeah. Okay.
Okay.
Now I'll just take you through this. What we have discussed is this concept called dynamic dispatch or late binding. So you have to, this will come into play only when we have a reference of type parent type and object is of type child. Okay, that's when this particular concept works. Dynamic dispatch late binding. So according to the runtime type of the object, which method to be invoked will be decided. So manager can redefine bonus, uses parent class bonus via super, overrides definition in parent class. So that method overriding is what we have done in the bonus method. We have given a new definition for the bonus method that we got from the employee class. This is what we have seen. Consider the following assignment: employee is equal to new manager. This we have seen, right? We cannot invoke set secretary method directly because of type checking problem again. And when you give e dot bonus of p, here what we have discussed so far, which bonus do we use? So during compile time, that is static checking, this will call the employee. Actually, it will check whether employee has bonus or not. And in dynamic, in the runtime, we have manager object, so it will basically call the bonus method of the manager class itself. This concept is called as dynamic dispatch, dynamic binding, laid method binding. Yeah, and this is a default in Java for all these instance methods and all. And yeah, what we have seen is we have changed the instance method itself, right? We also have this static methods and all. There, the concept will change. And you can just explore it. What happens when we have two static methods with the same name in child class and parent class? Default in Java, optional in languages like C++, etc. There, if you have to work the dynamic binding, you have to specify the function as virtual function. You have to give this keyword virtual. Anyway, let's focus on Java now. The concept is clear, right? According to the runtime, which method to be invoked is decided. The object that we create at runtime is the actual.
Ma'am, it will check inside employee class and calls the bonus inside manager.
So we have two steps, right? Compilation and actual execution of the
Yeah,
code, right? And
yeah.
when we do compilation, we can say that it will check m dot bonus, it will check the employee class, whether employee class has bonus method or not. Okay, that's why compilation check is successful. And during runtime, what will happen is it will check what object we have. We have manager object. So it will call the bonus method of manager class. Getting it?
Okay,
And if you do not have bonus method in manager class, it will basically call the bonus method of employee class itself because
okay.
it is inherited anyway.
But signature should be same.
Yeah, signature is same only. Yeah, this happens only when the signature is same.
Okay. Then we can return anything, no?
Mm. Like,
Yeah, like inside the manager class, we are returning 1.7 to be
ha ha ha.
1.5. Yeah.
Yeah, you can do anything here. We are giving a new implementation for the bonus method of manager class.
Okay.
Yeah.
Ma'am, in this case, the result we are seeing in the terminal, it is from the manager class, right?
It is from the
Finally.
manager class. Yeah.
Yes, yes.
I think maybe I can. Any this will not depend on anything, right? So we'll see. See what got returned. Whatever that we have
Yes.
here. Yeah.
Okay, but if we remove the bonus from employee, then it will not work.
If we remove the bonus from employee, it will not work. Correct.
Yeah,
It will
same
be
as
similar
secretary.
to
But we
the
can
sales.
but we can remove it from the manager class and then it will work well.
Ha ha.
Yeah.
Yeah. That is fine. That's like inherited method. Just so. Yeah. Maybe you guys will be having this thought: why we have to create the reference of one type and object of another type, right? So this will be useful when we have a collection of objects. Consider like this. We have class employee, right? Now we have class manager. Suppose we have another class assistant manager, CEO, director, many classes. Okay, and what we are going to do is we will have an employee array. Okay, now as you know, this concept parent class reference variable can be used to point to a object of child class can be used for array also. So we can have an employee array, right? And this employee array is having only two, the size is two, so it can store two objects. And what type of object I can store? Any object that is employee and its subclass, right? So first object I am having is of type employee, e1 new employee, and second one is manager, e equal to new manager. Now I have an employee object and a manager object, e1 and e2, and emp array of 0 is e1 or this, yeah, e, and emp array of 1 is m, which is manager object. So 1 1
There is
and
a
m,
type, ma'am. There will be
yeah, there
M
is a typo,
in
yeah,
it.
right. This is e and this is m. And here the first element of employee array is employee object, right? And the second element is manager object. Okay, and now you can have a for loop that is running through this particular array from 0 to end, and we can call the bonus method on each object just like this emp array of I dot bonus. So according to the object that we have, it will call the bonus method, correct? This is what we want. Getting it?
So, ma'am, it is basically like dynamic dispatch, but in runtime. It is like continuously doing that thing.
Yeah, this is a runtime polymorphism or dynamic dispatch, we can call any way.
Something like that.
So this is one use case. One second. Okay, is that clear?
Yes.
Okay, then yeah, typecasting. So we tried to access set secretary method, right? When we had a manager that was referenced by a type of employee, correct? Which was not allowed earlier. Now what we can do is we can do typecasting. We can convert the manager, sorry, the object anyway, his manager. We have to convert this E to manager type, right? So we can do type conversion and then call the set secretary method. This will work. So now see, it is working. We are able to get the get secretary method using M itself. We just did typecasting into manager. Is that okay?
Ma'am, internally what it is doing?
Basically, the type of M is now changed to manager.
Okay, got
Yeah.
it.
So here, the next point here we have is cast fails error at runtime if A is not a manager. So this is one another case. So if you are trying to, I mean, logically you think like this. If M is not actually an object of manager, and then if you are trying to typecast to manager, then that will give an error. Correct. So the best way is to check whether E is actually an object of manager or not using this particular operator instance of. So this particular, see here, if E instance of manager, we are first checking whether E is actually an object of manager or not. Only if E is an object of manager, then you convert E to manager and then call the set secretary method. So this is to avoid any error in the runtime. Clear?
Ma'am, this method too is like runtime. It is not static.
Please repeat.
Ma'am, this method is also runtime method, right? Typecasting.
Which method?
Like typecasting the class
Yeah,
to
yeah, yeah,
another class,
yeah. So the
object to
typecasting
another
is
class. Yeah.
actually, yeah, after creation of object, right? So you're checking whether the object that is pointed by is of actually a manager object. Then if it is so, then convert into manager, convert e to manager, and then call site secretary method. Okay. So this is just to avoid the runtime error. Maybe this will not give any error during the compile time if E is not pointing to a manager, because in a compile time we have not created the object yet, right? But runtime will get error if E is actually not an object of manager. To avoid that, we have to check and then typecast. If the check is true, then typecast. So we will learn about this more in I think week 5. Yeah, reflection, which means reflection means think about oneself, right? Normally, philosophically. But in case of objects, it is basically checking the state of an object or the object itself, what kind of object, these things. Okay, so what we have learned so far is, one is inheritance topic, where we had a class, then we have subclass. On top of that, we learned the topic method overriding, right? And then we learned about dynamic dispatch, which comes under polymorphism. And this is very related to method overriding, right? When we have subclass and all those kind of things. So we have entered into polymorphism, dynamic dispatch. We have learned method overriding. Next is method overloading. So don't confuse method overriding with method overloading. Okay. To avoid confusion, you can always think it of like this. Method overriding is like overwriting. You are giving a new definition for something. Okay. Now overloading, we'll see. Overloading is signature. So here it is given. Signature of a function is its name and list of argument types for this particular course. And here can have different functions with same name and different signature. So here see, we have something called class arrays. I think I have introduced you to the class arrays, right? So using the class arrays has lot of utility methods that we can use to do some manipulation on arrays, like sort method and other methods. So sort method basically take the array and it will sort and return it, right? And as Java is a statically typed language, we will have different kind of arrays like int array, double array, right? And we need methods to sort a double array, int array, and other arrays, correct? And uh, instead of having methods like sort double, sort int, sort other data types, what they did is, we have the concept of method overloading where the signature remains same. So if you see here, public static void sort, and it is taking double array. The argument is different, and here it is int array. But when you call a method, what you can do is, you can call any type, right? You can just call sort method. So here I have a double array of 100 size, and here I have int array of 500 size. And here I am calling the sort method as it is static method, calling it using the class name itself, arrays.sort, passing the double array. And here I am calling the sort method by passing int array. Do you see any difference in calling these methods?
No, ma'am.
No. So what we are giving is, we are giving some array and we know that we'll get the sorted form of it, correct? And how is it possible? Because we have a class array that has methods that are overloaded, which means the syntax, the signature is same, but it is taking different types of arguments. So this is called as method overloading. They are functions with same name but different arguments. Different arguments means different data type of arguments. Is that clear?
Yes, sir.
Okay, then I'm not giving more example. You can try, okay? Just add some two methods in class employee itself of same name. Just change the arguments. Maybe you can change the number of arguments, the different types of arguments. By that, you can get overloaded methods. And what do you think is the difference between method overriding and overloading? Method overriding happens only within two classes, right? We need class and a subclass. Then only we can say method overriding, correct? Otherwise, it doesn't make sense, right?
Yes, ma'am. Also, in case of overriding, the signature is also.
Yeah, entire thing, the signature,
Yes,
everything
yes.
is same. That first line is same.
Including the parameters also.
Correct. Yeah. Shall I move to next topic? Today it's fine, right? You're not overloaded. Okay. Next topic is multiple inheritance. Simple only, just listen and live. So we have seen inheritance, right? So class extending another class. And in multiple inheritance, the concept is a class extending more than one class. So we have C1, C2, and C3. So C3 is extending C1 and C2. A subclass, can a subclass extend multiple parent class in Java? So in Java, it is not allowed because if C1 has a method called f, public int f, and C2 also has public int f, now what will C3 get? What will C3 inherit? That is a problem. So um, because of that, multiple inheritance is not supported in Java. C++ allows this if C1 and C2 have no conflict and all. Yeah. Even Python allows it. But in Java, with classes, we can't allow multiple inheritance. In week 4, you will learn about interface. There you will see how we work with work with the interface for multiple inheritance. Now, yeah, any doubt?
Now, then how does Python carries out multiple inheritance?
Mm.
They have both same function in the different classes.
Please repeat. I
No, no, I'm asking then how does Python implements multiple inheritance if different classes have same method?
yeah. There they use the call some rule called left to right. It has a particular name. So the one which comes at the left side, the first class, it will take the method from that to solve the conflict. So different languages do it differently.
I'm not really understand. Can you speak?
So I will just take an example. The method resolution order, that is the term. So we have parent A, this is one method greet, and parent B we have greet. And child is inheriting parent A and parent B. And here, so when you create an object of child object, it is calling greet, right? And here, parent A comes before parent B, right? So you will, this greet will call this one, the left one. Yeah. Here to parent B. So it will call this one. The name is method resolution order. Yeah. Okay. Next topic is very, very, very important. So now you learned about inheritance, right? So we know we have seen class employee and class manager. Manager was extending class employee. And we have a class hierarchy, a tree like structure. Okay. And on top of that, we have class object. What it basically means is every class that you create in Java by default will inherit this class called object. So you see, this is capital O object, public class object, which is present in LAN package. Class object is the root of class hierarchy. Every class has object as a superclass. So parent class can also be called a superclass. All objects, including arrays, implement the methods of this class. And if you see the methods that is present in class object, we have clone method, equals method, finalize. This is deprecated now. Get class, hash code, notify. All this we will see in threading concepts. ToString, wait, and all we will see in threading concepts. So for now, we focus on this equals method and ToString method. Okay. So what is equals method? See the description. It indicates whether some other object is equal to this one to compare two objects. Okay. Yeah. So indicates whether some other object is equal to this one. So if you see this thing, you will feel a little bit tricky. So just see this x equal to y. So how this equals method is implemented in class object is to check whether two objects are pointing to same location or not. Okay, x equal to y, if it will return true only if x and y both are pointing to same object. Okay, and it will not check the contents of the object. It will simply check whether x and y are pointing to same object or not. Just the reference checking. What we'll do is we'll try to see it in detail. So remember that every class inherit what? This is like extends class object by default. Okay. Now in class date, what we have is three instance variables: day, month, and year. And here we have the constructor that is initializing day, month, and year. And as you know, equals method is present in class object, right? And what we can do now, we can override this method to do anything, correct? Or I'll just show if you do not override what happens. Okay, so here I have not overridden the equals method, and here I have in the main class main method I'm creating day to an object and passing 10 to 2022 and date to 15/6/2023, and here I'm checking whether date 1 is equal to date 2 or not by calling date 1 dot equals is a method, and by passing an object of date 2. Okay, let's see the output. Here I am getting false. Why I am getting false? Date 1 is pointing to this object and date 2 is pointing to another object, correct? Date 1 and date 2 are pointing to different objects, so we are getting this as false. If it is something like this, what will be the output? True. Now what is happening? Date 1 is pointing to this object, and here I have given date 2 equal to date 1, which basically means date 2 is also pointing to this object. So we are getting true. Is that clear?
Ma'am, it would be also same for the date 3. So,
What do you mean? Like same for how?
date 1 and date 3, comparing this.
Yeah, that's a good question. So here I will see date 1 and this one, date 3 is this one. Okay. Now see, date 1 equals date 3 or not? Date 1 is equal to date3 or not. What do you think will be the output?
It should be true, ma'am. Yeah?
No.
False.
False, I
False.
think.
It's a false.
Mm,
Why? Because date1 equal to here date1 dot equals date3 is actually checking the reference, and the reference, you see date1 is pointing to this object and date3 will be pointing to another object which has the same content, but they are different objects. So you will get false. Clear?
Yeah, ma'am,
Even
these both will have different memory location, na?
right, yeah. This will have one memory location and this will have another memory location.
Okay,
Because of
and
that, yeah.
yeah, and date one and date two will also have different memory location, but reference pointer is same.
Yeah, date1 and date2 are reference variables in the stack, and date1 is pointing to this object in the heap, and date2 as it is equal to date1, this will also point to same object in the heap.
Okay.
Yeah. Now you see, even though these two objects have same content for day, month and year, we got date1 equals date3 as false, right? Because it is comparing just the memory address or reference. Now what we want is, this is the definition that is coming from where?
object class.
Object class. That is how equals is defined in class object. Okay. Now what we want is, we want to compare the contents of date object and should return true or false according to the content. If day, month and year of a date object is same for two objects, I want to treat both objects as same, equal. I want to get true. How can I do that? I just have to override the equals method. Okay. So this is the, you see, public boolean equals taking object. So you see the argument, it is of type object itself. Okay. Yeah. Now, uh, here what we are doing. First, what we are doing is we are checking whether D is instance of date or not. Why? What we want is, we want to confirm that D is of type date. Okay. And then once we know that D is of object of type, D is of type date, then only we are trying to convert it. Then we'll typecast the D into date, and then you can call this particular normal comparison of day, month and year using equals. All right, this is normal primitive variables. So day, month and year, if they all are equal, here is AND operator. If all of them are equal, then return true. Okay, true and true and true will return true, and then otherwise return false. Let's run this again. Anyway, this will return true only, right, all the time. So I'll give some other. Yeah. Now see, date 1, we have 10, 2 and 22 for day, month and year. Date 2, we have 23, 3, 24. So date 1 and date 2, if you call equals method on that, then you will get a false. And for date 1 and date 3, you will get a true. That's how we defined equals method. You can define equals method in however you want. How you want to compare the content of two objects. Is that clear?
Ma'am, here D instance of date. Here D what it signifies.
D signifies the object that we pass. So here see, equals is taking object D, right? And what we are passing? A date object, date 2 of type date. Okay. And if you want to access the variables or methods of the subclass, right? Date is a subclass of object now. We have to typecast it. Otherwise, As you have seen in the get secretary method, you will get error, right?
Yeah.
Using the object reference, you cannot get all those details, all those values. So you have to typecast.
Okay.
Yeah. Shall I move to next one?
Yeah, ma'am.
Okay. So next we will try to see the toString method. You see the toString method that is present in class object returns a string representation of the object. In general, the toString method returns a string that textually represents this object. The result should be a concise but informative representation that is easy for a person to read. So, it is recommended that all subclasses override this method. The toString method for class object returns a string consisting of the name of the class of which the object is an instance, then assigned character, and the unsigned hexadecimal representation of the hash code of the object. So in other words, you can think it of like this. So it will, this get class got get name will return the name of the class. That is how toString method is defined in class object. So it will give the class name plus at symbol, then hash code converted into some integer form. So basically some representation of the object. Is it useful for someone who print an object? No. So what we have to do? We have to override this method in the class. Before overriding, we'll see what happens when we print a object, when we print an object. So here we have class animals. It has two variables, name and age. Here is the constructor. And in class main, we have the main method, creating an object of animals class, passing variables for name and age, and then printing out the animal object itself. You see, when we printed animal directly, when we printed the object, what we got? We got a string representation, right? Here is the class name, what we have seen there, at symbol, then some hexacode, right? Now, what we want is, we want a proper way by which the object is printed. Like we want to print the object in a proper way. Yeah, sorry. So what I want to print is, I want to print something like name equal to name and age equal to age. Okay. So what I will do is, I'll override the toString method. You see the signature here, public string to string, and here I'm returning name, the string, and then the name value, age, and then age. Now if I print animal, what's happening? So I'll get in this format. So when you print an object, how you want that object to be printed, that you can add in the toString method, right? Is that clear?
Yes, ma'am.
Okay. So this is very, very, very important. How to override equals method, how to override toString method. You'll see it everywhere. Okay. And this class object, this clone method and all, we'll see later how we can override clone method to create a copy. You know copy constructor, right? Copy constructor, with that you can create a new object from an existing object. Similarly, using clone method, we can do that. Okay. So this is same thing, just a few more points. Equals method, how we are overriding equals method. So if you have noted the equals method signature, it is taking object, right? And if you write something like this, an equals method like this, using date d in the argument, then this is not actually overriding the equals method of the class object. Clear, right? Argument, everything should be same as we have seen already. Yeah. Now overriding looks for closest match. So this also you would have noted. So we have class animals, and this class animals by default is inheriting class object. And we know that in class animals we have a toString method, and class object also we have a toString method. Even though we have toString method in two different classes, even though the toString method got inherited by animals class, the toString method of animals class got invoked, which means the closest toString method is getting invoked. Okay, that is what is written here. The closest one will be overriding looks for the closest match. Suppose we have public boolean equals employee but no equals in manager. Yeah, this is one good example. So we have class employee, we have class manager, and we have class object, right? So the order is manager, then employee, and on top of that object, multi-level. Now, if you do not have equals method in manager, then which equals method will be invoked in employee class, of employee class, or the object class? What do you think?
Could you repeat the question?
Yeah. So we have class object, right? And object has equals method. We know that. And we have class employee. And in employee, I will override equals method, which means basically I have a equals method in employee class. Now class manager inherits employee class. Okay. But I'm not overriding equals method, which means I don't have equals method in class manager. Now when you create an object of manager, and when you call the equals method, then which equals method will be invoked? Whether it is from employee class or object class. We don't have any way in manager class, but manager is inheriting employee, and employee is also already inheriting object class. And now we have two equals method, and which equals method will be invoked here by manager?
The
All
employee
the
class, the employee class.
Right, from employee class, correct. So it will look for the closest match. Who is closest to this class manager? The one who is sitting right top, correct? Manager extends employee, employee extends object. So on top of manager, we have employee. That is the closest match. So the equals method of employee will be invoked.
The object class is a super class. It's super class itself. It don't need to get created. It is already there, right?
Yeah.
Yeah.
This is by default anyway.
Got it.
Yeah. That is what is written in this slide. Okay. Next, subclasses, subtyping, and inheritance. Just the theoretical part. What is subtyping? Capabilities of the subtype are a superset of the main type. So, in context of programming, we can say the methods as capabilities of a class. Okay. Subtype is some class, right? Type is some class. Capabilities are the methods. Now, if P is a subtype of A, wherever we require an object of type A, we can use an object of type B. That is what we have seen so far. Employee is equal to new manager is legal. So as manager is a subtype of employee, we can have a reference variable E which is pointing to manager. This concept should be very clear. Okay. Can we do opposite of this? Manager M is equal to new employee.
No,
No,
ma'am.
that is not allowed. Yeah. Inheritance. What is inheritance? We are reusing the code of the main type. If we have seen the bonus method that we have seen earlier for the manager class, we have used the bonus method of employee class as well, right? We called super dot bonus to calculate the first part. Only then we have added more modification to that bonus that we get. Correct? So basically, we are reusing the code of the main type. B inherits from A if some functions for B are written in terms of functions of A. Manager dot bonus uses employee dot bonus. So here the same thing that we explained in week 1, we have seen dec, right? So which has these methods: insert friend, insert rare, delete rare. And queue and stack have only two methods from this list. So queue will have only insert rare and delete friend. Stack with methods insert friend and delete friend. And dec has more capabilities than queue and stack. So who will be the subtype?
Deck, ma'am.
Yeah, dec will be the subtype. Here, inheritance we can say can suppress two functions in dec and use it as queue or stack. That is how inheritance is related to this example. In stack, we will use only these two methods from dec and other two methods will suppress. Sorry. Yeah. So here you see what is subtyping in some different terms. Compatibility of interfaces. B is a subtype of A if every function that can be invoked on an object of type A can also be invoked on an object of type B. So take the case of a manager itself and the employee. B is manager and A is employee. If every function that can be invoked on an object of type A, which means on employee, we can invoke those functions on B, correct? All the functions that is available for employee can be invoked on manager, right? So we can say manager is subtype of A. Opposite is not allowed, as we have seen the case of set secretary method. Now for inheritance, we can say it is a reuse of implementations. We have seen that writing one function by reusing the code of another function of the parent type. So in Java, using one idea, that is a hierarchy of classes, to implement both concepts plus the distinction between the two. So here in Java, we won't see the difference between subtyping and inheritance actually, as we have already seen the examples where we have seen employee and manager and all, right? Is that clear?
Yeah, ma'am, please.
Okay. Then we'll see access modifiers. Next topic. We have already seen some of them. Anyway, let's see it again. So here in Java, we have some keywords called as access modifiers, which is basically used to control the accessibility, the visibility of the variables, methods, or the class itself. So we have this 4 access modifiers: public, protected, default, and private. So you can go from private, default, protected, public like this. Okay, let's start with private first. This is the most strict form of visibility. So when instance variables and methods are private, then as we have seen, they can be accessed only inside the class in which they are defined. Even in subclasses, we cannot access the private instance variables or private methods. Okay. Next one. Mm, okay, I think in our course we have discussed only two. Next one is public. So in public, if you make variables or methods as public, then they can be accessed anywhere within the same class, outside the class, different classes, subclasses, outside the package, or anywhere. So this is the highest form of visibility that we have. Yeah. And for protected, I'll just, or maybe we'll discuss this in another week where we introduce package. Otherwise, you will get confused. Okay. Now, for now, you just understand private and public. Private is very strict, only inside the class. Public, anywhere. Is that okay?
Yes, ma'am.
Yes.
Okay. Yeah. Now, we have two more keywords to discuss: static keyword and final keyword. Yeah. So, static keyword, we have discussed this a lot, right? Static variables are variables of what? Class itself or objects?
Classes.
Class.
Class itself, right? So you see, use static for components that exist without creating objects, correct? So math.py integer.max value. Math is a class, integer is a class, and max value is a static variable. Pi is a static variable. So we can directly access the pi variable from math class, just like this math.py, because those are static variables. Similarly, this applies for the methods as well. When we have static methods, we can directly use it using the class name. So we can also have something like public static components or private static components. Here they are asking whether private static components make sense or not. So if we have a private static variable, what does it mean? Private static variable. These variables are private. We cannot access it outside the class, but they are static as well. We can access it through what the class name. But if it is not private, how we can access it? So the use case is just like this. If you see, last order ID is a variable which is a private static variable, and here the use case is this variable is used across the objects, which means I want to update this particular variable whenever an object of order is created, right? So whenever this constructor is called, this particular variable will be incremented. So the order ID can be tracked using this particular variable. So this is used inside the class itself. And it will change whenever an object of order is created. Is that clear?
Okay.
Yeah. Next is final components. Final is used to make some variables as uh, constants. Okay. So usually used for constants, we can make some variable as constant, and when we create a final variable, then we cannot change it. Constants means we cannot change it, right? Pi variable we cannot change, max value, this cannot be changed. And for method, if you make a method as final, what will happen? Then it will restrict from overriding. We cannot redefine functions at runtime if you make a method as final. Suppose the bonus method in the class employee is final method, then we cannot override it in the class manager. Okay, is that clear? Only these four keywords: public, private, static, and final.
Yes, ma'am.
Okay. So yeah.
Ma'am, I am leaving because I have another class. So I will watch it recording.
Sorry, you're not clear.
Thank you.
You're leaving, you said, huh?
Yes, ma'am, I am leaving.
Okay. Yeah, fine. So yeah. Next topic is encapsulation. I think we have time, so I will complete this as well, okay? Encapsulation is again one of the OOPS concept. Okay, we have seen dynamic dispatch, which comes under runtime polymorphism, and only that, right? We have seen, yeah, inheritance also we have completed inheritance and Polymorphism we have started with one concept, method overriding or dynamic dispatch. Now we will see encapsulation. It's nothing but what we have seen earlier, okay, same thing. So encapsulation means binding together data and methods. So you see any class like this, here we have class tag, it has three instance variables and it has methods, right? So we have bound together all these variables and methods. Now the specialty is in Java, what we will do is we'll make the instance variables as private and the getters and setters as public. This is the combination. Okay, then we can say we have achieved encapsulation, which simply means when we have variables which are private instance variables, these cannot be changed or modified outside the class, correct? Only through the public access and getters and setters, you can access and change anything on these instance variables, correct? So that is how encapsulation is done. What does it mean? You have any doubt? Like,
But ma'am, if you're saying that we are declaring the instance variables as private, so
mm,
that it cannot be changed from outside the class,
mm,
right?
mm,
For instance, here you
yeah,
have a public class stack, but the private int values, I mean, there's an integer array and there's other two integer instance variables.
mm, mm.
But since we have made the methods as public, why can't other outside classes call these methods and change it? So what is the use of calling the instance variables privately?
Yeah, got it. So let's have an example, or let's keep employee with some name and int salary. Name int is hmm. Okay. See here, I have class employee with name and salary, and here is the constructor. And this name and salary are not private now. And here I'm creating the employee object and I'm assigning values here and some salary for this employee. And then in the next line, what I'm doing is I'm changing the salary to 0. Okay. Now printing the salary here. So in this case, what's happening? I'm able to access the salary of E1 and simply changing it. But the salary shouldn't be 0, right? And this is not, now the salary is not having any restricted access, correct? But once I make the salary as private, now I can't change it outside like this, right? And I can't access it as well. Now, what I will do is, I will adding, right? So it's a void taking some int value.
Ma'am, this record will be available now, ma'am, in YouTube.
Yeah. And then I want to check whether s is greater than 0 or not. Okay, and checking whether salary is greater than 0, whatever I am going to set. After checking only, I am going to assign or change the salary of the employee. Now, if I want to set salary for employee, I can set it using set salary method, and if I try to set it with 0, anyway, this has private access. I'll change. I'll have a getter get salary. Okay, now you see, I have tried to change the salary to 0, but it has not affected the salary, right? Because it's not greater than 0. So it is not changed, correct? So these kind of things I can avoid getting it. But if I make it just like a default variable, a public variable, then the salary will get spoiled by anywhere. Like anybody can change it. Somebody can make it negative, right? Understood.
Yeah, I'm getting it, ma'am. You can't. What you're saying is that we can't directly change the salary as
Mm.
an object to the as an instance variable to the object E1.
Right,
If
right.
if I can call, I get to set the by calling that function.
Right. This we need, right? We want to change it. We need permission to change the variable. We have to change the values of the variable, but we don't want to change it just like this. We don't want others to change it however they want. So it's like a restricted access. Now this salary will change only if it is a valid salary, correct? We can have any other conditions here, right? Any conditional checks, or we can check. Yeah,
Okay, ma'am.
yeah. So that is what we call as encapsulation. Okay. So let me stop it here. You can add the doubts in the document that Bhaskar sir has shared in the last session or in the discourse. Okay. Shall I stop? Okay. Thank you. Thank you, everyone.
Yeah, thank you, ma'am.